this question has a lot going on. The base idea is that you're going to do a chi-squared, which we'll talk about as we go through. We're going to need the row totals and the column totals for this table, so I did that for everything and wrote them down there. So I got the totals all written down. So it says right on the ratio of teenagers to non-teenagers in its simplest form for part D. So teenagers is 85, non-teenagers is 75. So 85 over 75, and I'm just going to use the calculator to reduce that. So alpha y equals 85 over 75, gives me 17 over 15. So then it says state the null hypothesis. So null hypothesis is always that they're independent. So preferred pet and age is independent. And alternate is that they're dependent. Okay, so I've got that. So number of degrees of freedom is rows minus 1 times columns minus 1. So it's going to be 4 minus 1 times 2 minus 1, which is going to be 3. Expected number of teenagers that prefer cats. Now I got to figure out that expected frequency table using the calculator, but this is just going to give you a review. So teenagers that prefer cats. So teenagers, cats. So it's row total times column total divided by grand total. So 55 times 85 over 160. So 55 times 85 over 160. $29.21875. So 29.21875. Okay, then it wants p-value. Now we have to remember how to do this. So in the calculator, we put the observed frequency table in matrix A, and then we make an expected frequency table in matrix B. In the expected frequency table, we can do right in the calculator by multiplying the row total times the column total and dividing it by the grand total. So I already did this. So to get to the matrices, you hit second, and then x to the negative 1 is matrix, and you go over to edit. So if I hit edit for A, make the matrix there. So I've got this matrix here in for A, this one right here, in for A. And then for B, so second matrix, edit, B, I got a 4x2, and then in each box I just type in what's going on. So for this first one, it was 85 times 55 divided by 160. So I just type in 85 times 55 divided by 160. 85 times 55 divided by 160. Okay, so I've got that in there. I must have had something typed wrong the first time. So that's my expected frequency table. So to get my p-value or anything else, I'm going to go to second vars, and I want go to stat, and then tests, and then there it's the letter C. Stat and then test, not vars. Stat, test, that one. So my p-value is 0.208. So my p-value is 0.208. If my p-value is bigger than my significance level, okay. So give a solution to this test. We're going to accept null hypothesis because 0.208 is greater than 0.1.